found here. Mean variance found here. And we say this is the vertex. And this side is efficient from here. And this side is inefficient from here. So right. This is the frontier between the diagram is about sigma's optimum sigma square
Hello? Hello, sir?
versus the
Hello.
Someone was
Yes,
asking.
please.
Sir, the upper part of the board is not visible actually.
Yeah.
Yes.
Thank you. Okay, sir. Is it better?
Yes, sir, this is better.
They can't see. Oh,
I think there is reflection over.
reflection, yeah. This reflection, so what do you do?
I think switching on that and switching off this.
Come.
Where is?
Same line.
Stand.
Whatever was there initially. Yeah. Right. Better?
Yes, sir, this is much better.
Much better. Yes,
Oh.
Good. Okay. So, yeah, I will write, this shape, yeah, that's okay. So, efficient from here and inefficient from here. And this is the risk versus return diagram. So, this is the return. And this is the risk. So, optimal variance versus the targeted return. That's what you sort of wanted to see. And main thing was we sort of said that what's the W, we sort of written that actual equation the last day. So just to keep it there, optimal sigma was the C by T, correct me if I'm wrong, B minus B by C square plus 1 by C. Yes. Yes. So that was the optimal sigma. And so we plotted this curve, sigma square versus B. Okay. So that's the one. Then the vertex naturally is this one, B by C. That's why we plotted the vertex. And then and then we sort of said that also when this is the minimal. This 1 by C. So this is 1/c. So basically, what should be the, and the minimum value, so WMBP, that is at this point, what is the WMBP? So we could have written that WMBP is B inverse 1 divided by 1 minus 1 times B inverse 1. So basically B inverse 1/c. And what else? I wanted to write also WB, WP. So yesterday I wrote in this form, W optimal, that means if you have a return, targeted return, then optimal W you can get as G times G the vector B plus H. This form. Where G equal to, you have to help me that here, where G is
Divide mu, B inverse into mu.
B inverse mu. Yes, minus
Like C by D is one time only with that.
only the B inverse T, okay? P by D, this one, and this might be P by,
Minus D by D into
yeah, B by D into
B inverse into one
one,
element.
right? V inverse one. So this is G, and there is H. Okay, H was the
A by D,
A by D,
B inverse
1 minus
A by D,
P by D.
D inverse.
Yeah. So this is the H. So basically what it means that this frontier has a special form of the W optimal, which is, if you know the targeted return, you already know what is the your omega. Okay? Here beta is 1. Right. Changing the graph, actually, you should solve for that. Changing the beta basically will sort of, if you increase the beta, as you see that is the weight, shape will little bit changing probably. That is going to be multiplier, right? So it is a multiplier there. So it will sort of say that you can actually find out exactly the solving the beta by 2 form, right? But he is saying that suppose I put a premium beta there, and if I solve this whole thing, then what should be the form? So that's a good question. I can put it in the mid cell.
But like we have to say like, so when you try to calculate the even if we try to include the beta term, like the weight would be getting would cancel, like would be cancel.
True, weight might cancel,
Yes.
but he's asking about the frontier.
Okay.
He's asking the graph of the frontier, how would it change? Yeah, so it might change this little bit shape, maybe taper down a little bit and so on. So the more premium you pay for the risk, that means you are putting more weight to the risk, right? So you are being a little bit conservative. Suppose beta is increased, so you are playing a little bit conservative, right? It will be tapered down. That means your targeted return will pay for more risk. That's all. So tapered down a little. So that's what he's talking about. If beta is less, on the other hand, it will be less risk you are asking. So that's the question he's asking. Okay. So the main part is that, as you see that knowing B, you actually know more or less everything. You know sigma square, you know the W and everything else. So that's the so your targeted return is giving you exactly the form of things. All right. So yesterday we talked about then WMBP we talked about, and then we said also wherever suppose you have a you want to diversify your portfolio. How do you diversify? In a way that is you can talk about one sort of omega versus one sort of omega means here like say mutual fund. Mutual fund would represent one sort of targeted return, right? And another mutual fund would be something else. So if you wanted to combine those two, so what is the kind of your expected how would you sort of form your portfolio in that sense? What should be your targeted return? So your targeted return can be something. Okay. So question is that, yeah, this is I'm sort of picking up the future from lectures in some sense. So often say that a market can be always can be formulated, or the every market portfolio or any portfolio in the market can be written as a linear combination of only two of them. Okay, only two of the portfolios. Okay, so that can be basically, it's called the two fund separation. It's a term called the two fund separation of the market. Then the market can be described as a linear combination of two funds. So only two funds. Okay, so right, that's the position of two funds that comes later. I mean, that's the one sort of hypothesis or one sort of postulate saying that, okay, market two fund separation in the market. So a market is said to have two fund separation when it can be described in a linear combination of two, any fund you choose, that utility can be described as a linear combination of two funds. There. So yes.
Combination of
Yeah.
So by calculating that covariance of omega 1r and omega 2r.
Yeah, that's what I'm trying to motivate you on that.
That we are not motivated.
Right. I'm trying to motivate you, right? So I'm trying to say that there's a background to it. That means basically saying that a market is said to have two fund separation. Now, question is that yesterday I did one more thing. Yesterday I showed that any convex combination of two frontier portfolio itself is a frontier portfolio, right? Yes. That's easy thing to do. If it is in this form, you can see that any convex combination of these, that means lambda times W1 plus 1 minus lambda times W2 would be exactly of this form. So it will be lambda times B1 plus 1 minus lambda times B2. That will be again one of the B's, plus, but H would be same, right? Because H times 1. Lambda times H plus 1 minus lambda times H would add up to H. Right? So that's why it is the resultant W is exactly the same form, G times some B plus H. So it must be frontier portfolio. So for all frontier portfolio is described in this form. Okay.
Even it need not be convex, but the summation is 1.
Yeah, if the summation is 1. Only requirement is summation is 1. It need not be 1, need not be convex. So that gives you the more freedom. That is basically saying that you take all is saying that because here it's unrestricted, right? Here all omega we are optimizing is unrestricted optimization. So might as well you take a linear combination which may be -2 times omega 1 and then +3 times omega 2. That will add up to linear combination whose weight sum is 1. Right? That's what all you need. So that is those things are allowed in this part, in this setup. Okay. And that itself would be also in the frontier. So that's what I'm trying to say. The two fund separation also saying that like if it is open thing, the two fund separation is trivial, right? Because yeah, I'm just saying that if a market allows all kinds of combinations, adding up to 1, that means all short sales in some sense, then two fund separation is obvious. Right? Any one can be found by any two of them. Right? Yeah. Okay. I'm saying that suppose it's unrestricted. The W is unrestricted means the way we have found out. Short sales are allowed. If short sales are allowed, then whole spectrum can be found as a linear combination of two, very easy. Right? Because suppose you have a W here, whose B is there, it's the B1, and this is the B2. Then take any combination of lambda times B1, plus 1 minus lambda times B2. Okay? That if you allow lambda to be between 0 and 1, then it will take out all these values. Right? If you take lambda to be beyond minus 1, beyond 0 and beyond 1, that means then it will take upper part and lower part also. So that means any two will actually give you the whole spectrum of the return. So that means if you allow unrestricted lambda omega, then actually any this part is always two functions. Can be written as a linear relationship. Is it clear? So that's a good thing that what is basically you can choose any two part and you can actually get best with something nice. Now, here is the main something I was trying to yesterday. Suppose you have one part separation like that. Which two points you choose? Which of the two points? That's what I was trying to do. So, should there be a relation? If there is a relation between the two, would you choose something that is covariance is non-zero or correlation non-zero? Would you choose something like that? You may or may not, because if you wanted to diversify, you wanted to have something which is uncorrelated continuity, if you wanted to say. But he is actually putting the saying, suppose I wanted to hedge, I want to take if it is negative correlation, right? Something is negative, I will have positive directions also. If that is possible. So you wanted to sort of check out on those things, you can actually. So first of all, that means covariance are of importance. Main thing, if you choose any two funds, your covariance you have to look for whether how it is, how the covariance can calculate, right? That was the first thing. So that is the first motivation, that if you have two funds, what should be their covariance? First, their correlation. If something is increasing, this also increasing, would you like to choose something like that? You may not. You want something really orthogonal to each other, or is saying the negative of each other is it the better thing? I don't know whether that's better. So that's why covariance of two of them optimal was of importance. That's what we were starting looking at. So that trivially it's one V2 of this form, and we showed that if W1 is LVP, then this covariance is always 1 by C. W1 or W2. So if this will be equal to 1 by C, if W1 or W2 is WM. That we showed last time. Right, thank you. W1 trans. So we have shown yesterday that it's very trivial. If you just put the what is W1 or W2 equal to, for MVP, the MVP we have shown, we have shown it. And that's very easy to say. Because 1 prime omega is 1, that's why. 1 prime of any portfolio is 1. Okay. So, but what's the general form for this? Remember, general form must be this form, right? So basically, you wanted to say this is something B1 and this is something B2, right? So that's what it is. So basically, you would be saying, okay, this is GB1 plus H prime B times GB2 plus H. Yes,
So that we can find it.
yeah, problem is to choose V1 and V2 so that you can have minimum value. That's one situation. Here we are not talking about first of that kind. We will be choosing something, we will be suppose we have two funds, we wanted to see the correlation first. Okay? And then of course we will be saying that whether uncorrelated is better or negative variance is better. That's the second part. Okay. So, right. So how do I compute this? And I will let you do the algebra in a many different ways. We have done this W. Actually, we can write W in another form, K,
Yes.
in terms of K as well. So if you write it in many different ways, one of the ways you will simplify much better than the other. And you can see that form is actually P1 minus B by C times B2 minus B by C plus 1 by C. Yes, something.
Something is like sigma square only given.
Yeah, exactly. I just wanted to write it in one line. Right, I would like to keep here. So C by D, B1 minus B by C, B2 minus B by C, plus 1 by C. This is the covariance. You can calculate, actually, you can actually show by liquid algebra. I think 2 or 3 steps it takes. Basically, you can write down in the form of K. That K form will give you easier way. But I'm writing this B1 and B2 because it's easier to explain this in terms of B1. So this form will sort of, let's say actually it's kind of nice. You will see that this is my covariance. As you see that it is negative always, not always. If B2, one of them is two sides of B by C. Then B1 is above or B2 is below or either way. But that doesn't guarantee the negative covariance. It has to, negative part has to dominate the 1 by C part also. So that also is there. Then there is the added 1 by C part, which has to exceed the negativity. That, you see? That is, this itself, this being negative itself does not mean it's negative. There's a one, not necessary. Yeah.
Yeah, just, you want different reads on the C instead of returns.
Right. So it is the return itself.
Same company, the same form with different reads.
Right. Two different companies, perhaps targets are two different things, or same company can be. I mean, you as an investor, it can be. Yeah.
The market is same, like that's what you.
Oh, market is same. Same market, definitely same market. Yeah. So, yeah, we are considering only one market with NDC asset. You can say my global portfolio can be one market. Your N can be large. That's also all right. Okay. So, right. This is as you see that this is a general form we are making for covariance. And if this is the covariance, you can easily solve that what should be the W for which we have a covariance is 0. What's the W2? Suppose I fix B1. What should be B2 such that this is 0, right? So huh? Yeah, this is easy. This is quite easy actually, because once I write in this form, this is kind of trivial in some sense. So B2, this implies that this factor B2 minus B by C equals minus 1 by C divided by, so, and P by C and then divided by B1 minus B by C.
Here, like,
So D by C square, if you see that, if I write down D by C square, then
so here we're fixing like the first investment. And
one of them. I'm trying to find B2 in terms of B1. That is, if covariance is 0, there's a relationship, exact relationship. Or in other words, I should say covariance is not 0. If covariance is equal to fix something, suppose you want certain covariance, then B1 can be written in terms of B, or B2 can be written in terms of B. So all you need to do, fix one parameter, then two others are fixed in that.
So even the earlier expression we have written, like sigma 2 square, sigma 1 square, and
Yeah.
sigma 1 2.
Exactly.
Is it same?
It's sigma 1, 2. This is sigma 1, 2,
Yeah.
I'm writing.
Sigma 1 2.
This is the sigma 1, 2.
Yeah.
Right? This is the expression sigma 1, 2 we have written.
So we are only fixing sigma 1 2. The expression we have earlier, like,
Right,
and the expression we have now.
right.
After
Right, exactly. So what I'm trying to say is that if you pick sigma 1 to value, then knowing sigma 1, you know sigma 2.
Yeah.
So I'm saying that 3 parameter is not independent. Sigma 1, sigma 2, and sigma 1, 2. These 3 are not. If you know sigma 1, if you know sigma 2, sigma 1, 2 is known.
so when we are saying that fixing V1, that means that we are fixing sigma 1. Right?
No, fixing
Sigma 1, and we are fixing V1. By that we are saying that we are fixing sigma 1. And
Yeah.
like here sigma 1 2 is there. Is we are very easy to and seeing what's happening.
Yeah. So basically that's what I'm saying. Sigma 1 square and sigma 2 square and sigma 1, 2. These 3 things are not independent. So any 2 of them if you know the third one. So that's the important part here, because wherever you wanted to find the minimization of variance, these 3 things are not independent. So you can represent one of them in the form of other.
How much we go to same the reason was when I go sigma 1 sigma 2 sigma 1 2 already. So why is it?
Why is it?
Why is it explain the nature?
Why is it sorry? Right. We are not independent means if I know B1, if I know B2, then I know sigma 1, 2 also. Right? So that's what are the variables? Basically sigma 1 square, which is variance, sigma 2 square, that depends on B2, and sigma 1 that depends on both B1 and B2. Okay? All I'm trying to say, there are only 2 unknowns, B1 and B2. So 3 things cannot be, all 3 things cannot be independent. Right? That's why. Right? Is that make sense? All right. So that means B2 equals, we can write this as B2, I'm just using the board, B2 equals B1, this negative itself. So I'm writing this in terms of the other. So the another line you will be adding saying that B2 equals B2 minus B by C is equal to this, but B2 equals B by C minus. That's it. Okay. Good. So this is when covariance is 0. Graphically, actually, how do you find? Graphically, there is a very nice representation. Graphically, suppose here is B1. Okay? Let's say this is your B. I can draw here. That's fine. Suppose this is your B1, right? Okay. Where should be B2? You have 0 coordinate.
I mean, sir, it's like a tangent. Sir, it's like a hyperbola.
This is not hyperbola, this is a parabola.
For the B one, it could be like B two is all like inverse of B one, so it's like a hyperbola.
Right, yeah, you are right. It is, if you say it as a function, it is like a, hyperbola. 1 by C, but you see there is a negative also, but positive part as it added here. So little bit different hyperbola is a 1 by x equal to 1 by y, that's the rectangular hyperbolic form. But if it is x equal to 2 minus 1 by y, what's that could be?
Like, if we take, so, if we take, I mean, one by one, for example, hyperbola with two non-ECPC between two kind of.
So change of coordinate.
Draw x by x equal to 2 minus 1 by y, what does it look like? X equal to 1 minus 1 by y.
Like, the thing is, here we're shifting the origin to B minus C, and like multiplying the xy, if we're taking two variables xy.
Yeah.
Here we're changing the origin to B minus C, and multiplying the multiplication of those two variables is a constant, that's what we are saying. So if we consider that to here, okay, so we take a difference between B one and B minus C. And like we are searching for some variable like the variable B2 and the difference of that B2 and B2 minus B minus C. The multiplication of that is a constant, like
Good.
between.
Yeah.
So like you're asking where is it?
Yes,
So
and you'll be surprised when I draw the line.
okay, but no, it should be a point.
With limited,
It should be a
with
point.
limited value, right? It's not it's not, I mean, unlimited graph. It's a, so, yes. So where should the B2 be? If B1 is here, so where should they, given that it's a parabola. Parabola in the sense, this is x versus y squared type of parabola. So. So line passing through this point, wherever it cuts, that point is the,
But it's not passing through, right? I mean, it has to be 1 by C. No, when B is B by C, say. Then we have. It is 1 by C.
so let's try to show that, let's try to, this is called secant line, yes. Right, so what you say, basically the graph between B1 and B2. He just drew the graph between B1 and B2, how it did look like, it is actually it is not unrestricted graph, it's a restricted zone. So the minus sign is there, so that's why it's restricted only, because it cannot exceed the plus something, 1 minus 1 by y, right? Cannot exceed 1, that's why. So, but here I'm representing actually, not exactly that graph particularly, I'm representing here with respect to this frontier, where that should be. Okay, with respect to the frontier. How should I show this? That's very good question. So, first of all, what's the coordinate of this one? Coordinate of this one is B1, not B1. It's a sigma 1, let's say, sigma 1 square. Okay? And comma B1. And I know the value of sigma 1 square already. So sigma 1 square would be, that means that one, right? C by D. B1 minus B by C whole square plus 1 by C. Right? That's one. Good. And so I'm claiming that, I'm saying that I wanted to prove that this is B2, right? I want to prove this is B2. B2 means given by that one. So what I'm saying that I draw a line from B1, sigma 1, B1, sigma 1 square B1 through the vertex. So what's the vertex position? Vertex position is the 1 by C and B by C. Right? Good. So I draw a line actually passing to these 2 points. So let's find that out. So it is y minus this is my x, this is my y. So y minus b by c. Right? And it was y2 minus b by c. So b1 minus b by c divided by x2 minus x1, so sigma 1 square minus 1 by c. Good. Times x minus sigma 1 by c. X minus 1 by c. You are with me so far? Good. Okay. So that's fine. So what is sigma 1 square minus b by c, minus 1 by c? Sigma 1 square minus 1 by c is this part. So let me replace this. So I can write one line here. B1 minus b by c divided by c by d into b1 minus b by c square. That's it. And times x minus 1 by c. Good. Okay. Now, last step, sigma 1 square by this one. 1 minus 1 by minus 1 by c gives me only this factor. So, is it b1 minus 1 by c gets cancelled by square? So, only 1 by c remains here. So, I can write that line to allow me. So, I can write this is d by c divided by b1 minus b by c times x minus 1 by c, right? So I can write it here, x minus 1 by c. Now it's still here.
Now we take x equals 0.
Now x equal to 0.
But not in, like, intuitively how should we think, like, just asking.
Intuitively, how it should be.
I mean, how should we think, like, that it should pass through the.
Right, right.
From that, what we get.
From there, how to get it. Basically, that's the idea is basically here. I mean, you see that when you try to have, you know, what should we say that?
Oh. Yeah,
Yes. So what's the covariance? Covariance is this form. So I think the idea of secant line is the
so for a hyperbola, like, I mean, it's the center is this. Okay, we have two portions of hyperbola, and if we are drawing a line from one point passing through this origin.
yeah.
If this is on one side of the one part of the hyperbola, and this is on the other part of the hyperbola. Is it right?
Yeah, basically when you say B1, it should be on the same side, right? Because I think the hyperbola here too, it looks like B1 versus B2 graph on this one. It's sort of, he said that it is like I think this one versus this one only limited. Right? That's what you do. So if B1 is this side, then B2 is also this side, right? And
But our origin is even.
that's what you do, right?
That's the other way around.
You mean here,
Yes.
this and this, okay. Right. Oh, this is the positive side. This is the positive. This the other, this we are drawing negative, right? Right. This is the P1 versus P2. Right? Only limited, not unlimited. Remember, it's only limited.
the center, I don't know, I forgot the name, but like the center is BVC comma BVC for the B1 and B2.
Both device, yeah.
Yeah, and when we're trying to draw a point passing through, a line passing through the origin, like I mean, we call it origin. From one point,
Got
now,
it.
it has to be on the other side of the graph, right? I mean, like, what I'm trying to say is that, you know,
Yeah, yeah. It's,
so this is the origin. If suppose this is the point, let's say, oh, if both B1 and B2 are on the same
Yeah.
point, like
same,
point.
yeah, same point, yeah, same size.
Mhm. Like, okay, that's different what else.
Right, yeah. So, so this is basically related by this one, I mean, the question is that how should one should think about something like this? So only way perhaps that, I mean, I think the relation is really, interesting in a way. So, we can think about only, yeah, it is really. Huh? It is more like a ratios of these two in something, ratios are product of these. How can the product be expressed on these things?
Yes, you said that it has to pass through that point.
Yes.
We found for 0 to 0.
Right. Yeah, this is the value for, that's what we have done. Basically, this actually gives me that y. So when that is x equal to 0 implies y equal to b. Yes. That's all. This all gives me, right? X equal to b, y equal to, on this line. So the same thing, if we think about this is the variance versus the return graph, right? Suppose we do it by standard deviation versus return graph. What does it change? Versus return. That means I'm doing the sigma 1 versus the b. Sigma versus b. Sigma optimal versus b.
This. Sorry, right?
How does graph change? I mean, how does this graph change? Sigma versus. That's the relation, sigma versus, right?
Yeah, yes. Like, I mean, that is. Sorry.
Because of those points.
Locus of this. Hyperbola. X equal to something ay squared plus, right?
What is the question? Sorry.
So x squared, I'm saying that if I do standard deviation versus return, here I have done variance versus return, mean versus return,
Yes.
variance, right? Mean variance frontier. Instead of I do mean versus standard deviation frontier. So mean versus standard deviation frontier is actually in this form, right? X squared plus equals y squared, cy squared plus ay squared plus b. This form, yes. So that's a hyperbolic form. Okay. So hyperbolic form, and then all you will see that this graph will be little bit upper side, and hyperbola is more flatter, right? This is more flatter. And what do you expect this line to be? That if it is more flatter, now you can guess actually if it is not if it is more, huh? Line would be V2 may be over, but the line, how does the line behaves compared to the graph? Line should be on top of the graph rather than cutting the graph, right?
Okay, line should be like as one floor.
Tangent,
And
tangent to the V1, from V1, if I draw a tangent, then it will cut V2. B1 and B2 may be at the same place basically, because B1 and B2 doesn't change, right?
We need to show.
Yeah, you can actually show that, right? Now I'm saying that suppose I change the graph. Mean versus standard deviation. Should I change the graph?
Please look something.
Right, I'm doing that, right? Just for me. I've been in some. Because it's one board, no, and that's why I'm, otherwise I could have done there, but that's okay. It's not
Wait for camera, they can see.
right, I could have done in the other side also. Somebody has to hold the camera.
Sir, I had just very important that.
So here is sort of the graph would look like. More flatter, of course. Okay, vertical.
Yeah, okay, I,
Right?
we fixing beyond B2.
Yeah, B1 and B2 are fixed. You say B1 and B2 doesn't change the value.
But,
Covariance is zero. Covariance zero means B1, B2 are fixed.
yes.
B1 is not, B2 is fixed. Yeah, what I'm saying that why it is, it should be, it can go beyond. What I'm trying to say is, you are fixing the graph and the lines, then straight line between B1 and B2. Now, instead of cutting that, suppose you are flattening the parabola. I mean, hyperbola is more flattened, right? If it is more flattened, that in the outside part would come in, right?
Yes.
Because it's flattened more. So outside part would come in, that's why the line would be above, little bit above hyperbola.
It need not be, right, like just asking, it need not be. But here we are saying that it is.
It is. Okay. It is. In this case, actually, it would be the, definitely it is, and, I think if you prove for general, parabola to hyperbola, that kind of thing. Remember what we did here, we haven't changed the equation, all we are saying that, thinking that this value as x or this value as x square. So any equations of that kind would be same. Do you see what we did? We actually thought that this as x versus this y squared or something. This is a square form. This is a basically quadratic form. And we first initially we thought that this is x. Right? And we are making the graph x versus b. And here now we are saying that this is x squared. Okay. Equation is same. This is x squared. And then this x equal to, we are drawing the x equal x versus. So that's the change. In this setup, there will, of course, one can show geometrically that that has to be done.
Like the implication of that is like, is if we're drawing the elements, we are drawing it normal to the, I mean, it is perpendicular to the normal to the line.
Perpendicular to the, yeah, of course.
So, like, what does it like represent? I mean, like, mathematically, what does it mean? And, like,
Oh, it's a line joining the point,
yes,
and so if you have a line, if you have a
what's the
point,
implication of it? Like,
yeah, I'm coming to implication. Basically, I'm saying that if it is basically a suppose you have again same point. Now it is the equation is sigma 1 versus not sigma 1 squared versus p1. Okay, so you are drawing a line passing through a point tangent at the point. Okay, to the curve. So that curve, wherever it hits the y-axis, that's the point we are having the meet. Okay, that's the. So, and your question is what's the
implication of like having a point B2, B1 and B2, like this, where if drawing tangent and we're finding the intercept, like y-intercept and saying this is B2. So what does it mean? Like orthogonality, something like that.
No, this is exactly, oh, you were saying about the orthogonality. Yeah.
Yeah.
Okay, that's a good point, actually. So you can say that this is this is basically saying that this is tangent means the sort of orthogonal to the this, right? Orthogonal to the normal at that point. Tangent is orthogonal to the normal at this point. So in a way, suppose that is at this point, suppose we have two vectors. So then, of course, that two would be orthogonal at this point. But remember, this actually is not the normal to this point.
Yes, yes,
So you have to remember that.
yes,
This is not normal to this point.
yes.
But this one is tangent. That's true. This is a tangent connecting point here. So orthogonality of this vector itself, you cannot just mention at this point, right? By saying that that is the tangent point. Orthogonality of, so you are looking at, yeah, I think I see what you mean.
And you say covariance is 0.
Right, I see what you mean is basically that omega prime be omega 2. This is equal to 0, right?
Yes.
Right. So, yeah, that's a good point. So what you are trying to say that in some sense that you are actually coming from that is two vector, right? What are the two vectors which is orthogonal? Orthogonal vectors are this and so these two vectors are orthogonal. So if you do in a product between these two vectors are orthogonal, right? So b to the power half, right? Because w is yeah. These two vectors are orthogonal. So brackets. So and so basically I'm trying to say that suppose that is how how does that representation would look like? That's the main thing. That means put the representation immediately tells you that this is B. I don't yet cannot say exactly for the moment. So where would this vector be? I do not know exactly at the moment, but you can, that's a good point, good question. So does it represent that this one and this one immediately? Okay. So that V1 omega 1 would be defining on that direction. That's the important. Yes. So we can stop here. Only thing that I wanted to do that here the tangent, because then next time I can talk about two-part separation. So tangent is very easy actually. So
You want to find the equation.
tangent. Equation of the tangent line, yes.
But why it also, why
I will see that, just one. Equation of the tangent.
Equation of tangent.
So, equation of the tangent.
We can find the equation of the tangent, but why?
Huh?
Why is it tangent?
Why it is a tangent, right? No, why it is a tangent, remember I give the intuition. Intuition is very clear.
Go break up the purpose, right?
Yeah. Why it is right? That's a good one. Yeah. So yeah, that's actually very simple. Not very simple to tell you. I have to think about it. That's what I
You
mean.
can find the equation.
Right. So here, what does it mean? It is really y minus y1, x prime at x1. So all you need to do, this is your f, right? So what is your f? So that is dy by dx, I put that. Dy by dx, that is easier to equate. At the point x1. So this is your x1 y. And then you can write here 2 x dx equals c by d 2 y minus d by c d1. Right? So which implies dy by dx equals x by d by c, sorry, d by c divided by a, multiplied by x divided by y minus d by c. Okay. So that's your dy by dx at the point x1. So this is your x1. So this is the x1. And if it is x1, then this should be y1 also, right? This should be y1. Okay, so you are all set there. Basically, that means this is equal to P by T. X1 means sigma 1, and then times V1 minus V by C. Okay. And then this is x minus x1, x minus sigma 1. All right, x minus sigma 1. Okay. So all you have to do put x equal to 0. Okay. So if you put x equal to 0, then this is sigma 1 square. Right? This is sigma 1 square, and then you write the whole thing there. You will have c by d, which cancels out. The first term will be d1 minus this. So you will write down that equation easily. So at x equal to 0, this value is d by c multiplied by c by d times d v1 minus d by c square plus 1 by c. That's in the numerator. Minus, yes, minus. All throughout this minus. And then this is just v1 minus d by c. So first term, it is just cancels out and just remaining v1 by d by c. So first term is the minus v1 minus d by c. And the second term is minus d by c squared times 1 by v1 minus d by c. Okay. So that's it. Y1 is v1, right? So that means
What is P two?
y1.
Oh. But T would access zero, right?
At 0, right? Oh, okay, at 0. No, y is at 0. Which means y
Sorry.
equal to v1 minus v1 minus d by c minus d by c square v1 minus d by c. So that means v1 minus d by c only gets you d by c. So that's
That's the same P two we have.
same. That means the story is this. That means if you have a parabola of this form, if you call it x versus a sum square y minus d square whatever something you can write and f or e. Then if you change the graph to root x, okay, then this is x versus y. If you change the versus root x times root x versus y, that means that graph will have this kind of property. So it is not about the mean variance formula, it is about the hyperbola parabola idea. So
Second.
yeah. So if you write down x squared here, then 0. So if you think this is as the x and draw the graph this as a parabola and changing that was x squared versus hyperbola, then that's the property. Okay. Okay. This I can this. So this. Right. So next Monday is the regular class 2 to 4, right? 15 to 4. Monday, Thursday. Two to 4 and 4 to 6, right? 4 to 6. Yeah.
Only put.
That's right now.
Thank you.
return is negative for every stock. And why if it put the stock as matter?
That's like in game one, game two scenario, right? When the returns are negative, you choose the bigger variable, you have to go ahead with higher probability. Remember game one, game two?
Also very high, right?
No, we say that if you are choosing the, remember, we say that probability of, bigger than, if I want to find the P of bigger than equal to C. And if C is, I mean, if C is something like bigger than some number, it need not be always positive, it's bigger than equal to something. This one is going to loss also. If that number for game two is always bigger, this progress, and we showed that. So that's why you are saying we suggesting that at least one of the objective will satisfy. Of course, some objective you see is very low, you wanted to protect from the much loss. I mean, you say wanted to say that, for example, I believe -5 or something. We showed that then that will change, right? Your objective is probably will change. Have I showed this that? Either game one will be preferable if C is too low, too much negative.
Yes.
Because bigger than 1/90, -1/90, or less than -1/90. If it is less than -1/90, then numerator will be negative, right? Then you will denominator bigger means numerator negative, so it will be the lower cost. Lower possible problem, right? Numerator negative, denominator big means you are closer to 0 from the negative side. So probability of bigger than would be less amount of area. Then numerator negative by lower variance means lower variance means further from 0. Then you have bigger area from the right side. So that's why probability is bigger. That's why lower variance would be when you are trying to protect too much loss. But you are little bit ahead of that, then you are always better off with the positive variance. I mean, the higher variance.
So sir, this implies, what is the higher variance?
Yeah, you see, the objective is different. Objective is saying that how much loss you are protecting. If you are only interested in little bit loss and winning more, then it's better off with higher variance. If you are trying to protect much lower loss, I want to be bigger than equal to -5. I want to be bigger than equal to -10. Then you're better off with the smaller.
Well, then it is subjective, right?
Yes, it's subjective. Your subject. That according to that objective function is equal, or equivalent function is equal. That's one of the criteria. Actually. He's talking about the mu equal to C1. Then. Good point. I can put it in the list. Oh, this one. Yeah, any questions? You all good? I'm closing the window now.